Can you hear me? Yes, yes. It's great to be here. I guess with COVID, face-to-face meetings and conferences like this have become scarce, and it's great to be back. It's really good to be back. Great to be here in Valencia. I've been learning some Spanish. Not enough to do a talk in Spanish, I'm afraid. I know una cerveza, por favor. And today I learned the word Toritos. But don't worry, I won't be doing the talk in Spanish because my Spanish is dreadful. I'm afraid it is in English, and I know it's after lunch. A lot of you are probably a little bit sleepy. I try and make it entertaining, but let's see how we get on. So today my talk is on a headless CMS called Umbraco Heartcore and JAMstack technologies and how we've used it to design for scale and performance for our customers. So I'm Andy. I am the technical director at Tangent. I'm more of a back-end developer, be warned, than a front-end developer. I know this is kind of a front-endy talk. But we will be talking about what JAMstack is. We'll be talking about the benefits of JAMstack, how we've used Next.JS and React to deliver static site generation and pre-rendering. And we'll also be looking at our Azure infrastructure around implementing a JAMstack approach. And that's probably a little bit more me, the infrastructure side. We have 2 case studies as well. One looks at global distribution, and the other one looks at handling unplanned spikes in traffic. And we're talking about millions of users in very short periods of time, and we had some interesting stats on that. So JAMstack. JAMstack isn't what I had for breakfast today. JAMstack stands for JavaScript, APIs, and Markup. I guess to sort of sum it up, we use JavaScript to pre-render markup. There's the term called pre-rendering is something I'm going to use a lot today, and it's the key point of the talk. So we use JavaScript. We use something like React or Gatsby or Next, and in this case it's Next.JS, to create markup, to pre-render markup. And then we create APIs to call anything we can't pre-render. So any dynamic data, like a share price, you wouldn't want to hard code or pre-render into HTML and distribute via CDN across the globe, because it might change. So we use APIs to pull those things in. So the benefits of a JAMstack architecture, one is performance. We see staggering performance compared to traditional server-side rendering, and we have some stats we compare our Umbraco CMS to a Sitecore CMS, and the stats are outstanding. Cost saving as well. There's a lot less compute, there's a lot less infrastructure required, and in Azure terms, that means less cost. We also look at sustainability, and it's something at Tangent that we are very hot on, I guess. I was at the Azure conference in London, the Azure Summit in London, and Azure have changed their 6 architecture pillars now to include sustainability. And I think every single person in this room, as people who commission software, or write software, or manage products or software, have a responsibility from a sustainable approach. So this is something I'm going to go through today, and I'm going to try and put some real-life data around carbon emissions of server-side rendered platforms compared to JAMstack architecture. The last benefit is developer experience. With decoupled front-end applications and microservice architecture, developers can work in isolation. We can deploy in isolation, and it's not the same as a monolith where you have all of the headaches of all trying to merge the same thing into a monolith or same code base and all the problems that may cause. There is a 5th advantage as well, which is an error that's on my slides. But the 5th benefit of JAMstack architecture is security. The attack vectors compared to a server-side rendered platform are greatly reduced by taking this approach, and that's something we're trying to illustrate as well. So, what is JAMstack architecture? Let's start with the basics first. Let's start with the traditional website and what the traditional website works and how it differs. So a traditional website, you have a user, they're on a client, they make a request. It will be routed through by maybe some load balancers, whatever it might be, to a web server. The web server will get the request and think, what am I doing with this request? What do I need to do to create this page? So it might go back to an API server or an application server, which could call a cache or a database or pull something from another API, and it might do some thinking, chug away a lot, go through a lot of downstream dependencies to create a HTML page, which will then be passed back to the client. And that is not the fundamentals of JAMstack. That is the fundamentals of a server-side rendered application, and it's the old way of doing it. I like to think it's the old way of doing it. So what is JAMstack? To start off with, we've still got a user. They've still got a browser. It's nothing too dramatic. But instead, they hit pre-rendered HTML. And this was the thing I was talking about at the start. So on build or on a change of content for a CMS, like a publish event, a delete event, or an unpublish event, we will recreate statically generated HTML in something like Node, but you can also do it in Go, you could do it in Python, you could do it in .NET. All of them have static site generation features. And that pre-rendered markup would then be put into a CDN, which means the user would only ever hit the CDN, and they wouldn't end up hitting a web server, an application server, et cetera, et cetera, et cetera. It means that the performance is much higher, incredibly higher, actually, and we'll show you some stats around that. It also means it produces significantly less carbon. It costs a lot less in infrastructure costs, because let's face the facts around like any cloud platform. You pay for the amount of data you send, you receive, and you also pay for your compute. They're the fundamentals. But here, you haven't got any compute. You only compute on an event rather than computing for every single request. So it's a really fundamental switch about how you approach developing websites and hosting websites. And then, as I said before, for anything you can't pre-render, so you can pre-render your homepage, you can pre-render all your content, but you might have pricing data, or you might have a share price, like I mentioned before, or you might have a user profile data. And for all of this, we use APIs, and we pull all this from caches that we try and make as close to the front end as possible to make sure we have performance, but we can't pre-render these things. So to do this, we've used Next. Next is a library for React. This is hosted in Node, and we use it for static site generation. So we get our contents from an API, from a CMS, from a headless CMS, and we use a few at Tangent. We use Contentful, Content Stack, Umbraco Heartcore, Optimizely, Episerver have all released headless products for their CMS platforms now. I think pretty much every CMS out there, from WordPress now has Atlas, for example. They all have headless offerings, not headless offerings, as I nearly said then. So we get the content from the CMS, from APIs. We hook into this on build of our application or on publish or whatever it might be, and the Node application running Next and running React will then take the API content and use something called SSG, static site generation, to generate the content. And this will produce a HTML file, which is then put into a cloud storage, like blob storage, if you're only serving to a local market, or if you're serving to further afield, you might put a CDN in front of it. That means then the browser connects directly to the cloud storage device, gets the HTML from there every time, not creating the markup for every request, and returns it to the user. The only other piece of the puzzle there would be what we do with live data. So from the client, then we create async calls that hit APIs that would then call any further data into the client for stuff we can't pre-render. So your share prices, your user data, your live pricing data, whatever it might be, you've probably all got your own use cases. There are some other terms to bear in mind as well. We talked about server-side rendering. There's something called incremental site revalidation as well, and this is how we invalidate the cache. So we're creating a pre-rendered file, and it's like a cache in Redis or a cache in an application cache. You can set a cache time for it, and when that expires, this is what we use something called incremental site revalidation to recreate that page. So it recalls the APIs and recreates a copy of that page. Next user to come into the CDN or the cloud storage will have a cache miss, and they will be redirected to the Node application, which will create it that one time for every cache miss. The other thing we can do is something that's come out with Next.JS recently, and it's 12.1, it's a bit of a game changer for us, is on-demand revalidation. That means we can programmatically call an endpoint in the Node application and clear the cache per page. So that gives us a whole wealth of possibilities that didn't exist, and Next 12.1 is something that's come out maybe in the last 2 or 3 months, so it's fairly new. So what are we using this for at Tangent? We have a couple of scenarios. We've delivered this model for a few clients now, but the two I'm talking about today is how we handle unplanned spikes in traffic. We do a lot of work for national infrastructure providers in the UK, and when there's an issue with the infrastructure, they see incredible volumes of traffic hit their site. And it's not like Black Friday, where you know it's the end of November and you're going to get this big amount of traffic. It happens, and you'll be, I'll be at the cinema with my kids, or I will be painting the garden fence, and suddenly there'll be like, there's been a huge outage with this infrastructure, and the traffic's gone up. The sort of volumes we're seeing are 20,000 concurrent users. So to put that into perspective, a concurrent user is someone doing something in a single millisecond. Google.co.uk, the search button, has around, on average, not at its peak, 30,000 concurrent connections. So it's pretty high volumes of traffic we're seeing. And this is millions of people in a very short space of time. The other part of it, the other client or the other use case we've used it for requires global distribution. And because we're using CDNs and we're pre-rendering the markup, we can globally distribute it on the edge network. And that means that everybody gets blisteringly fast performance, sub 2 seconds load times. In China, in Europe, in South America, doesn't matter. That's big, right? That's really big. Compared to the server-side rendering, where you might be hosting it in Northern Europe, for us, for example, it means the problem of network latency and requests is solved, and we've seen some great results of it. So here are some tips and tricks that I wish we had known when we started out on our journey. One is how we handle events from the CMS, the order of events we handle them. Next is how we handle caching, search, and also considerations around content models. And these tips and tricks here you're going to get in the next 10 minutes will save you lots of agonizing pain we went through, and I wish I kind of watched myself give this talk maybe 9 months ago when we were starting out on this journey. So, first of all, CMS-driven events. We use something called Umbraco Heartcore. We're Umbraco Gold partners. There are other headless CMSs out there. This principle applies to every headless CMS. It's not unique to Umbraco. You can apply this to Contentful, Content Stack, yada, 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 yada. Inside any general headless CMS, you can create webhooks. We create webhooks for publish events of content, for unpublish events, and delete events. These webhooks are then subscribed to by a bunch of Azure functions. We're currently with the functions on our Kubernetes migration journey, so if I ever do this presentation in a year's time, it will be pods and nodes, not functions. But it's functions at the moment. So we have separate functions for all of our webhooks. We would then take these functions and have the classic pub-sub architecture, where we take the markup that comes from the webhooks, and we publish it into a queue. I was at an AWS talk this year, and I heard a quote. I don't remember the source of the quote. I wish I did, but it doesn't matter. I can give you the gist of it anyway. They said, if your system hasn't got a queue in it, it's probably a bug. And I tend to agree with that. We have a service bus. We're using Azure. Obviously, we've got functions and service bus. It could be any queue you want. And we have different topics for different items. Topics are queues in service bus. And this service bus is at the heart of our system. It's like the beating heart of our system that orchestrates all of the events coming in and controls our cache and our revalidates and all that kind of stuff. It's important we have a queue because we have lots of users, and we could be subscribing to the CMS endpoints. We could be subscribing to lots of endpoints that call data. And every single request would call a re-static creation of those files in Next, which is an expensive transaction. Especially imagine if you have 500 pages in your website and somebody changes an item in the navigation. That means you have to republish 500 pages. That's an expensive transaction. We need to be able to control the order of transactions, the order of events, and the sequence of events. And that's why it's super important for us to have a queue at the heart of our system, not just for the events coming from Umbraco Heartcore, but from the events from any other APIs that we're putting static content in and we're pre-rendering. So the next thing is how we handle cache. Again, we have our service bus at the heart of our application. And this is subscribed to directly by an app service running Node and React. And we hook into on-demand revalidate, and we get an item. On publish, it's great with Umbraco, because on publish, you get the full JSON structure from the webhook for the object you're publishing, which means you can recreate the page, and you can include all of the nodes and everything you need from the JSON structure, and it has everything you need there to create your pre-rendered page. This is then cached or purged in something called Azure Front Door. Azure Front Door is a WAF, a CDN, and we use it for routing. It's on the Azure Edge network, and it means we can globally distribute our applications, we can handle incredibly high volumes of traffic, yada, yada, all the things we were saying at the start. So this is all absolutely rosy for publish events, but for the unpublished events and delete events, the item in the CMS database has disappeared. And Node needs a URI or a path to be able to invalidate its cache. And most CMSs just provide us a content ID. So how do we get the path? This causes a few gray hairs, maybe a couple of sleepless nights, but we figured it out. So we've got an ID, but we don't have a path. This is where site search comes in, and we use the same technique we'd use for invalidating cache for unpublished and delete events as we would for site search. So, search. Again, the service bus is the beating heart of our system. It orchestrates all of our events coming in, and we know the sequence of events and the sequence in which we need to process them. Again, we have two functions. It will be cough, nodes, and pods one day, but at this point, they're functions. One to remove an item from an index, and you're probably guessing what's coming next now, and the other one to update an item from an index. And we use something called Azure Cognitive Search. It's a Lucene index. I like Elasticsearch or Solar. It's the managed service offering from Azure, and means we can index all our items in there. At this point, I guess, if we had a request that came in and we didn't know the URI or the path, we can pass the ID in before we clear, when we subscribe to the webhook, we can pass the ID into the function, and we can use our search index to find that item. And we can also use our search index to get the URI and unpublish that item in Node, and also unpublish it in Azure Front Door. So this is all good. We're all good here. There was other complications as well. We're not going to go into too much detail about that, but around relationships inside CMSs, where you have a page references another page. So you might create a link to a page and have an ID for a page, and that generates as a URL. With this, we had to again use Azure Cognitive Search for those pages, find all of the pages that reference that particular ID, and then clear the cache for those pages. In addition to that, we use it for site search. We have a function that's running Nest and can query, run all our fuzzy searches and stuff like that on Azure Cognitive Search. And again, that's routed by Azure Front Door. So any async requests coming from the client for search, we would then route via that function to our index. So this is how it all fits together. We have, oh, wrong one. I was going for the laser there, I was being a bit cocky. We have Umbraco Heartcore from a CMS perspective. We have our publish, unpublish, and delete functions to hook into those webhooks and get the changes. Everything's processed via service bus. Again, it's the heart of our application. Node is responsible for our static site generation and our on-demand revalidation, so we can hook into that and recreate the cache. All of which is cached in a CDN at Azure Front Door level, and also has WAF on our routing for all of our API requests. We have separate functions for updating and removing items from our index, and our index in this case is Azure Cognitive Search, and we have site search as well. So that's the really 100-mile-an-hour, I hope I didn't speak too quick actually, someone told me not to, but that's the 100-mile-an-hour overview of how we put this system together. Now, one more slide. One more thing to talk about, actually, and I did mention this briefly, was shared items in content structures. So when you have something like the navigation, and you make a navigation change, or you have a footer item, thank you, and you make, am I back on? Brilliant, thank you very much. Probably got sweaty heads. When you have shared items like search or footer items, if you make a change to those, it's incredibly expensive because you have to republish all of your content. In the old days, in CMS applications, we got told you should put these things into the homepage item, into a settings tab into that. And we did. And we figured out that editors couldn't make an update to the homepage banner without republishing the entire site. So one important tip will be to take any shared items out of the homepage content models and make sure you abstract them into a settings, a decoupled content item inside the CMS that would then have those items in there so editors can change the homepage without republishing the whole site. And you also probably want to be give a bit of a warning that you shouldn't be making lots of publishes to settings, because with one of our applications, we had 500 pages, and our Node application and Next took around 20 minutes to build those. So it's a consideration, right? You need to be careful. That means a content editor is going to take 20 minutes to see their change. So the benefits. We had performance. We had costs, we had sustainability, we had better development experience. So cost comparison compared to Sitecore. This is from Europe, and the Sitecore application is hosted in Europe. So with Sitecore, we saw average response times of 4.22 seconds. These are now down to 1.41 seconds. And the Sitecore response times were 4 seconds in Europe, from Europe, where we see globally sub 2 second response times from our pages. Next, Sitecore cost a fortune, and so does the infrastructure to facilitate it. We saw an 85% cost saving from moving to the JAMstack architecture, which actually paid for the projects themselves. So if you're thinking about this from a solution, you have someone that's holding the purse strings. If you have high infrastructure costs or high license costs with big enterprise-level CMSs, this approach could be saving you money and pay for the cost of the projects that deliver it. Next is sustainability. So the old Sitecore application produced 1.44 grams of carbon per load of the homepage. The new application produces 0.2 grams. Now, that means nothing to me. But with the spikes in traffic, we saw unexpected users of 1.2 million users hit our application on a weekend through an unplanned instance, which would result on the Sitecore application a total amount of carbon produced of 1,700,200 and something grams of carbon, 1.7 tons of carbon. That is the equivalent saving, well, actually, step back. First of all, domestic flights in Europe roughly cost between 255 and 275 grams of carbon per kilometer. So that incident, we saved the same amount of carbon as 5 flights from London to Valencia. And that's a website. 5 flights. And to be honest, people don't just hit the homepage. People probably hit 3 pages. So we're probably looking somewhere between 10 and 15 flights worth of carbon were saved by us taking this approach. And I said it at the start, but we all have a responsibility. Every single one of you in this room has a responsibility from a sustainability perspective. The planet is going through an existential crisis, and we need to start taking sustainable approaches to infrastructure and our application architectures. I was at the Wired Security event pre-COVID in 2017, and there was a stat I heard there that kind of sent a shiver down my spine. The internet produces more CO2 than the aircraft industry in 2017. There are now less planes in the sky because of COVID, and people are using the internet far more because we're working from home in a distributed model. So those stats are going to be greatly exaggerated, and I will urge every single one of you to start thinking about the carbon emissions of your products and how you manage them. Lastly was development experience. So Sitecore was a monolithic application. This is going to be news to any of you. Sitecore was a monolithic application. Developments are a pain in the and deploying to a microservice architecture where you can deploy isolated deployments to individual pieces of infrastructure based on what we're changing, like a change to the decoupled front-end application, or a change to the individual microservices is much more efficient, much less risk, and takes much less time. So that's the end of the talk. I work for a company called Tangent. We have a stand outside. If you're interested in this, please come and see us. We work for a bunch of enterprise-level clients, from SAP to Regis. We're currently hiring, so if this is exciting as well, please give the GitHub guys a shout or us a shout, and we can look to see if you can come and join the team. I've been Andy. Please, if you have any questions or anything like that, come grab me afterwards or reach out to me on LinkedIn. But thank you very much for your time, and hopefully see you soon. Bye-bye.